have more models that we're going to look at here. Some are multiplication and some are division. I'm going to show you the lattice multiplication model. Okay, I'm going to multiply 31 times 43. So I make a lattice, and the lattice is formed. It's 2 digits. So we make the 4 box, and then connect your diagonals. Okay. Now, so 31 times 4, we're going to do it in pieces. So we're going to look at 1 times 4 is 4. So I automatically write the answer down in the in the triangle that's farthest to the right, or the lattice that's farthest to the right. And I put 0 in the other. Then 1 times 3 is 3, so I do 0, 3. Then here, 3 times 4 is 12. So now I have a tens, the 1, and then the units place is always, again, the triangle that's farthest to the right. Okay, and then 3 times 3 is 9, so I have 0, 9. Now, to get my answer, what I'm going to do is I'm going to look at my diagonals that I have here. Okay, and I'm going to add these numbers up. Alright, so here's what I'm going to do. There's nothing to add to 3, so my answer is 3. So then I have 9 plus 4 is 13, and then I carry 1, so I'm going to put it up here. Alright, then 2 plus 1 is 3, and I go on around my lattice, and then 1 plus nothing is 1, and then this is the number that I write down, 1333, 1,333. Now let's double check and see. 31 times 43. So using the multiplication algorithm, I have 3 times 1 is 3, 3 times 3 is 9, then I put my 0 to hold the place, 4 times 1 is 4, 4 times 3 is 12, and then I add. Now notice right here what I've got. I don't have anything to add to the 3, I add 9 and 4, I don't have anything to add to the 2, and then I have a 1, okay? So when I add here, I do indeed get 1,333. Okay, so let's look at another lattice here. Let me get a piece of blank paper, and let's do another lattice. Let's do Let's do 29 times 13. Alright, so 9 times 1 is 9, and the 0 goes here. 9 times 3 is 27. The units, again, is always to the right. Then I have 2 times 1 is 2, so it's 0, 2. 2 times 3 is 6, so it's 0, 6. Now, in this instance, I'm going to add nothing to 7. Then I'm going to add these right here. So I have 9 and 2 is 11, and 6 is 17. And I carry my 1. Then I add these 3. So I have 2 plus 1 is 3. And then there's nothing to add here. So my product then is 377. So let's check. 29 times 13. 3 times 9 is 27. 2 times 3 is 6, and 2 is 8. 9 times 1 is 9, and 2 times 3 is 2. And then I add 8 and 9 is 17. So I do indeed get 377. Okay, lattice multiplication. Now, might be something that you might see at a later point in time. John Napier was in the early 1600s, and he invented something called Napier's rods or bones, which is very similar to the lattice. And they actually were used in India first, but John Napier's being given credit for working with them. Okay, now, let's look at the repeated subtraction model. All right, I want to divide 6 into 726. So if I look at this, I want to see what I can do here. So let's say, okay, I know 6 times 100 is 600. So I'm going to subtract 100 sixes. Okay, and I'm left with 126. All right, then I know that I could subtract 10 sixes. Okay, now watch, we know that we actually could have subtracted 20 sixes, but we don't need to. We can just do the 10 and get 60, and then subtract and get 66, and then I know that 10 sixes would go into that, and I subtract and get 6, and here I know that I've got 1 6, so that 121 sixes equals 726. Now, if I took and I looked at a way that I learned division during modern math back in the 60s, early 60s, we do a division algorithm. It's a little bit different. See, this is typically what we do when we actually divide by longhand, and this is the model that I learned. So 6 into 726 goes 100 times, okay? And I have 100 times 6 is 600, and then I'm left with 126. And now this could go more, but I don't have to divide by the largest one like we do in our division algorithm over here. Alright, so that then I could say, well, I know that 6 20s would be 120, so that goes 20 times, and then I know that 6 into 6 goes 1 time, and all I have to do then is add up each of my individual quotients, okay, and I get 121. Now, this kind of gives you an idea. See, this is a little bit different than this, but the concept is still the same kind of thing. See, there's an extra step in here, but we end up with exactly the same answer. All right, now, if we look at the normal way that we do long division, I'm going to look at and only move one place at a time. So 6 times what is 7, so that would be 1. And then 1 times 6 is 6. And I subtract and get 1, and then I bring down only my next digit, which is 2. Then 6 times 2 is 12. So up above that 2, I put a 2. And then 12 minus 12 is 0, so I don't have a remainder there, but I bring down the next 6, and then 6 times 1 is 6, and then when I subtract, I get 0. So 6 times 126 equals 726. So multiple ways to look at division. Okay, now, I'll put that up, excuse me, here in just a minute. But for right now, what I'm going to do is I'm going to model 726 divided by 6, and I'm going to go back and use my base 10 blocks. So 726, and if I think about this, I have these huge blocks, okay? So I don't want to use these. I'm going to use my method that I did in some of the other videos, and I'm going to show 700 as some relatively large boxes here. Okay. Now, that's 700. Now, 20 would be 2 longs and 6 units. All right, now, if I'm going to look at this and I'm going to try to divide this into 6 equal pieces, okay? So if I try to divide this into 6 parts, I've got to figure out a way to do it. So let's look here. 1, 2, 3, 4, 5, 6. So if I take that, we're good to go. But now, what do I do with the rest? I can divide these in 6 different parts, but I can't divide what's left here, so I have to do some trading. So these blocks, remember, represent 10 longs, okay? So I've got all of these 10, 20, 30, 40. So if I broke this apart, I could break that apart now. So I'm going to mark it out and give me 10 more longs. Let's see, I had 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I want to divide this into parts of 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I'm going to put a circle or a ring. That's a group of 6. And that's a group of 6. And then here, that's a group of 6 there. So in units place, I have 1 circle because I've got 1 group. In longs place, which is the second, I have 2 groups. And in flats place, which is the third one, I have 1 group. So 726 divided by 6 is 121. Okay, let's do another one, just to make sure we've got it. Okay, now we know this is going to divide out evenly, but let's see what we've got. 400, 1, 2, 3, 4, and then we have 20, so that's 2 longs, and then 2. Alright, so I'm going to divide each part in groups of 2. That's a group of 2, that's a group of 2, that's a group of 2, that's a group. Oh, that was not good, was it? That's a group of 2. 1 group, not 2 of them. So I have 2 groups here, I have 1 group here, and I have 1 group here. So in units place, I have 1 group. In longs place, I have 1 group. And in flats place, I have 2 groups. And 422 divided by 2 is 211. Okay. And that's it for division model.